went out to the electrical component storeroom in the barn and found a good looking stator. Now the box was labeled 79 TX 440, so we got that. And a clean looking flywheel with starter hub. I guess we were lacking that as well. We're going to want to get in here and wash that flywheel out. And CDI box, it's marked TXL, but I think it'll work on this sled. I'm going to look around to see if I have something marked 440TX. I think they're the same, but we'll put the flywheel and the stator on before we get too much further. Now, these later ignitions have marks, and if you refer to the service manual, there's 3 marks. I think one is for 250/340 TX free air. The next one is TXL liquid, and then 440 TX. So we'll just look at the book for that to be sure. So I did have it a little backwards. The top line is for the TXL. Being a liquid, it can probably, and having better cooling and tighter tolerances, it can probably stand more advance. And then the 250 and 340 TX free airs, and then the 440. Now the 440 has a different stroke, so it'll affect the timing, but so the 440 goes on that mark. So hopefully we're very close there. Just a little fine tweak, but we'll put it perfect. We should probably use an impact driver, but I'll probably be taking this turret apart before long. The drawback to this end cover being machined off, as you recall, was I think we're supposed to have 5 bolts holding this housing on, and we're down to 3. So I have to just be wary of that. So our stator is in and timed, hopefully. The recoil housing is on, I put a little bit of WD-40 on the tapered shaft. Now we've cleaned the flywheel out, all the little flecks. It was pretty good, really. But a hint, if you've got lots of iron filings in the flywheel, of course they're magnetic and they're hard to wipe out, but go to the dollar store or stationery store and get some of that Plastitac stuff. You stick your papers on the wall without putting a hole in the wall, and that takes the filings out. It sticks to that, so it's non-magnetic. So anyway, we'll see if our key is a little bit dinged up in there, so I'm just hoping our flywheel will go on without a big argument. There. Now, as I said, the flywheel is a little bit dinged up, so what we'll do, I think we'll just put the nut on. Now, I've got myself in trouble. I don't have a way of holding the flywheel. I just realized that, so a bit of an issue. Let's try the right nut. This is the one that came with the flywheel. Yes. So I didn't have a way of holding the flywheel with the recoil rewind housing on, so I've taken that off. And years ago we rigged up a little chain wrench that by theory will hold the flywheel for us. Saw that in an old ski rule manual years ago, and I think 30mm is our socket size. Now I just want to tighten this up so that I can, because the key is a little damaged, we'll put it on and then hopefully get a lock washer on there if there's enough room. And I'll be the guy taking this flywheel off if it has to come off, so. I wish I had noticed that the key was a little bit banged up before I put the crank in the cases, so we could have even taken a die grinder and fixed that up. So I think the approximate torque for a Polaris flywheel is 60 to 65 foot-pounds. Go up to 50. And we'll go up to 60. Next step is to install the cylinders and the pistons. Now I know I don't have everything I need here. I've got no wrist pins, no needle bearings, no circlips, which should be in stock around here with any luck. Anyway, before we do that, I wish I had ordered a new set of rings for this motor. And I didn't. So we'll see what the ring end gap is like. Now, these engines are so easy to take apart that if we don't get great compression out of it, I can easily put rings in it, maybe pick some up. But the chrome looks scuffed up, but it's not flaked. And the exhaust side looks clean as a whistle, which is where, if the engine is overheated, you'd think there'd be damage. So it'll probably run good. So the procedure here is to take the ring off the piston carefully, They have been known to break. Put the ring in the bore and push the center of the piston in the bore with the piston ring in the bore, and then get a sense of the end gap. Well, there's a pretty good old end gap there, but I'm not seeing any daylight around the cylinder, around the ring. So we'll get our feeler gauges out and measure the end gap. I'm going to say we're probably at 15 thousandths, which is out of spec. Here's an 18 thousandths gauge. Yeah, and that drives through there, so we're like 20 thousandths. Here's 20. And that's driving through there like a... So, I'm sure there's a 25 here. That's as high as we go. Now that's tight. So we're somewhere around 20 thousandths. I'm sure the spec is 8 to 12 thousandths, so we're out of spec on the ring end gap. We're going to put it together and run it and see what happens. Because this obviously was a running engine, because there's no marks on the piston. They are a Fuji piston, made in Japan. It's got the Fuji logo, and there's our friend Art in there. Thought I saw Art's name. Something to do. No Art here. So, and we'll have to find some base gaskets. I don't know if I have base gaskets and head gaskets either. We dug around in our bins. We found wrist pins, factory wrist pins, which are outside cooling off right now because it's going to be a tight fit. And a neat little plastic bag that said 440TX. And inside there were our needle bearings, these little metal fancy spacer washers that Fuji used back in the day. Set of 4 of those, and circlips. So I tried to fit the wrist pins, and they're tight, so we have to heat these pistons with the hair dryer or the air gun, and get them to just expand by 1,000th or 2 to get them in. So we'll work on that. Now the piston gets very hot from the air gun, so you definitely need a pair of gloves for this job. I've cooled the wrist pin off outside. Not sure if this is going to work, so let's give it a try. We seem to be there. That wasn't pretty. we've applied some two-stroke oil in the cylinder, so we have some startup lube, and this cylinder is counted mag, but the exhaust port's got to go out the exhaust side of the motor, so you really can't go wrong. The other thing is, these are stock Polaris pistons, and the little arrow points to the mag on Polaris. A lot of sleds, the arrow points to the exhaust, so you got to be careful. But it's common sense. Where the ring butts up against the locating pin, you want to make sure that's not over the exhaust port where the ring ends will get caught. Now, anybody that's done any two-stroke work will know this, but I'm just mentioning that for anybody that's starting to tinker with this stuff. So, it takes a little juggle. I mean, these are very, very easy compared with a Polaris triple, XLT triple. That just pops on like that, and down we go. A bit easier to do when this piston's at top dead center. We'll just do this again on the PTO side. You can see now where the rings butt. I've got serious concerns with these rings. They sure don't have a lot of tension, but maybe we'll order a set. So the trick is to hold the ring in with one hand. And slide the cylinder over. If it doesn't go easily, there's something not lined up right. And again, these are super simple compared with some. Something I didn't mention is, I read in a manual years ago, every step along the process you should turn the engine over just to make sure nothing's dragging, scratching, banging. A lot easier to correct as you go slowly. So anyway, there we are. Looks pretty good. So now we have to find some 10mm nuts and washers and lock washers. Now, all this stuff has come to me loose, so I don't know. And probably a good idea would be to get the exhaust manifold. I see we need some studs. Get an exhaust manifold and lightly bolt it on there to align the cylinders before we torque those bolts down, because you know, they will tweak a little bit, and I think you could put on unnecessary stress in the engine by not doing that. So we'll start digging in our parts bin.